Good morning. Thank you all for coming out to the AAUDE Data Visualization Challenge. My name is Wayne Talaferro from the University of Maryland. I represent the Office of Institutional Research Planning and Assessment. I'm joined by my colleagues in that office as well as a colleague in the graduate school. And we are participating in the inaugural Data Visualization Challenge for these two particular exchange items, which are near and dear to us in Maryland as we participated in the development of some of these metrics. And we're also very aware and affected by, as many of our peers are, the national conversation and local conversation as well around graduate education. And we're really interested in how we can continue to use data to inform the decisions we make on campus in the conversation that generally is being had right now around graduate education, specifically doctoral education. I'll go right into the comparison group that we used as we go through the presentation so that orient you all to that group. We're going to use Big Ten institutions. Maryland just joined this year. There are 14 institutions in the Big Ten, including Maryland. 5 of the Big Ten institutions from the 13 outside of Maryland did not have data in AAUDE for our selected programs. And 3 more did not have fully comprehensive data in all the time to degree fields that we were interested in. So that left us with a comparison group of 5 institutions from the Big Ten. We chose 2 programs to look at, economics and chemical engineering. Both of these programs had comprehensive data, and they also had data that was diverse and expansive enough for us to be able to make the kinds of comparisons for this particular example of data visualization here. I'll move right into our first item that we'll be looking at, which is the doctoral completions item. Just to orient you all to this exchange item, it looks at new entry cohorts of students in the fall and shows how many of them have completed the program, as well as how many are still enrolled, or not yet still enrolled and not enrolled by the time the data is pulled. In this case, it'll be the year 2013. Also, just to be mindful, there are some inherent differences in program structures at different institutions, so the data might vary just inherently by that very fact. So for our first program, economics, here you can see we have 3 cohorts of students and 3 cohorts of data that we have pulled. We're going to focus on the fall 2006 as that's going to be the example that we use for our visualization moving forward. Here you can see that in fall 2006, the entry cohort of students in economics was 36. So there were 36 entering fresh-faced doctoral students. 58% of those students had graduated by 2013. An additional 17% are still enrolled, and a quarter were no longer enrolled. Moving forward, we looked at the data based on how many students had achieved candidacy. So by 2013, 75% of students had achieved candidacy. And of those that achieved candidacy, 79% had gone on to obtain a degree. We look at the data in bar chart form. So Maryland's at the top. You can see our completion percentage as well as our cohort size and that of our peers below. The faded extended bars represent the amount of students who are still enrolled in the program. And we order that data from top to bottom. Here we look at our chemical engineering program. So looking at it the same way and focusing on fall 2006, you see there were 6 students that began that term. That 50% represents the 3 students that went on to complete, and the 50% that are no longer enrolled represent the other 3. Looking at the data again based on the percentage of students who achieved candidacy, 50% of them had achieved candidacy by 2013, and 100% had gone on to obtain a degree. Again, the data in bar chart form, Maryland at the top and our peers below. The faded bars represent the amount of students who are still enrolled. And we order the data from lowest to highest completion rates. Now we're going to switch and talk about our time to degree data. So the difference here is that the times to degree data are based on a graduate degree cohort, or graduation cohort. So how many students earned a doctoral degree in their respective programs in a particular fiscal year, and we count backwards to see how long it took them from the time they start to the time that they obtain a degree. We also want you all to be mindful that just like completions, the data are inherently different based on program structure at the institution. And so here in this exchange item, we're able to not only count back from start to finish, but we also count 5 different metrics in between that time to be able to demonstrate the full experience time-wise for a doctoral student. And different programs and different institutions are structured a little bit differently in what that experience looks like for students. So we just want everyone to be mindful of that. Here we're focusing on the fiscal year 2013 degree cohort. So everyone that earned a degree in fiscal year 2013 in a particular doctoral program, and here in this case chemical engineering. Maryland at the top, you see there were 7 graduates with a median time to degree of 4.3 years. And that increases all the way to 5.3 years, which represents that 1-year difference you can see in terms of just what the variance looks like across different programs at the different institutions for this program. We look at the data again in a little bit of a different way. Here you can see the blue and red bars actually represent the median number of years before a student enters candidacy, and then the yellow bars represent the years within a program spent after candidacy. And so here you can see how that variance plays out a little bit more intensely, with there being a 2.9-year difference between the lowest and highest number of years post-candidacy in the chemical engineering graduate program. We do the same thing with economics. Here you can see Maryland at the top. There is a median time to degree of 6 years, and the lowest time to degree here is 5.3 years. So a little bit less variance than before in the chemical engineering program, and a little bit longer time to degree. We break the data apart again by pre and post candidacy median number of years. And here we see that variance explained across the different institutions, with there being a 3.5-year difference in the amount of time it takes students to graduate post-candidacy. And so these small differences and benchmarks that are included into this particular exchange item are able to provide us with a more nuanced grasp or lens into the actual doctoral time to degree experience. Lastly, we looked at the data based on pre versus post candidacy ratio of time spent in a particular program. For chemical engineering here, you can see we have these clocks that represent the time pre and post candidacy for different institutions. Here you can see the percentage of time spent in a program before students reach candidacy. And the yellow proportion represents the percentage of time after candidacy. Again, with economics, here you can see pre-candidacy percentages and post-candidacy percentages. And before we leave, I want to just provide some brief takeaways that I think are some really good capture points for what we displayed to you and what we think is important for everyone to go away from this presentation with. So these 2 exchange items were designed in a way that they can be used collaboratively to be able to provide a more comprehensive perspective on the doctoral experience at different institutions and at your own institution. We recognize that there's a lot of potential with this data as well. So, for instance, you can get a sense of not only the quantifiable experience of students in terms of how long it takes them to get the degree, but you can start to benchmark it against your peers, against national norms, against your own different programs internally, and then also be able to look at it when you're thinking about program review and accreditation and allocating different resources. And then lastly, as always, with any data set, there are some limitations. And so we just want folks to be mindful. A couple that come to mind, for instance, occur in our times to degree data where the clock is continuous. So stop out and drop out behavior are not accounted for, such that we might see some misrepresentations if there are instances where there are students who may have dropped out or stopped out for a period of time. And lastly, I want to make sure I acknowledge my colleagues who were instrumental in putting this presentation together. I've already introduced myself, but my colleagues Emily Foley, Stephanie Dollamore, and Thomas Dobraszewski in the Office of Institutional Research Planning and Assessment at Maryland, and Sham Akhtar in the Graduate School, all colleagues that were very instrumental in putting this together.